Jnanam Paramam Dheyam. Knowledge is supreme.
Welcome to this 11th lecture of this organometallic course entitled Advanced Transition Metal Organometallic Chemistry. We have been discussing a very interesting topic over the last two lectures, and these are about transition metal cyclopentadienyl complexes, particularly with respect to their synthesis, and more importantly in the last lecture we have looked into their structure and bonding. By structure and bonding, I mean we looked into atomic orbitals as well as the molecular orbitals so formed from the atomic orbitals of the cyclopentadienyl ligand, and then their subsequent interaction with the transition metal orbitals. Now, in this discussion, let me just recapitulate what we had spoken about in the last class, so that we can build on it in this class and take it further. In the previous class, we had looked into the atomic p orbitals of the Cp ligands, and based on their symmetry based combinations, there are 5 p orbitals resulting in 5 molecular orbitals, and of these 5 molecular orbitals they fall into 3 classes. One is A1, molecular orbital which is fully bonding in nature, versus E1, these are degenerate set of orbitals with having one nodal plane, and then subsequently E2, they are again a degenerate set of orbitals having 2 nodal planes. So, A1 having 0 nodal plane, lowest in energy, followed by E1, followed by E2 having 2 nodal planes, and these are also degenerate 2 orbitals. So, these orbitals are formed from linear combination of atomic orbital based on symmetry. Now, when one looks into the metallocene transition metal orbital interaction, then one has to consider 2 CPs in eclipsed or in staggered conformations, and that is illustrated over here. So, in this case what we had shown is there are 2 Cp in staggered form. The reason the staggered form is chosen because between eclipsed and staggered form for ferrocene, the staggered form was found to be more stable. Having considered the staggered form where 2 Cp's are mutually facing each other in opposite direction, so as to get a staggered conformation, we were looking into the various metal orbitals that would get involved or get interact individually with A1, E1 and E2 type ligand orbitals. In our last class, we have also looked into this interaction starting with E2, where the metal orbitals of different symmetry reacted with E2. Now, these metal orbital reacting with the ligand orbitals, these interaction is of delta type. The delta type means that these are face on interactions where one face of the d orbital reacts with the face of the Cp ligand, and what we had seen that there are 2 possible combinations of these interaction. One is E2G with the dxy orbital. G is the Gerardi symmetry. Likewise, one can have a opposite symmetry of U type, and then the metal orbitals reacting for this is d x square minus y square. These delta interactions are weaker in nature compared to sigma and pi interactions, and then we are going to discuss that in bit more details. After the delta interaction, the next interaction is about the pi interaction, and the ligand pi orbitals are of this type. And the metal orbital interacting with it d y z, and this is a pi type interaction. Now, these are set of degenerate orbitals and similarly the opposite combination and that reacts with P y of the metal this also is a pi type interaction. So, these are E1g orbital and also involves a pi type interaction. The orbital involved is d x z. Similarly, the other combination is as shown over here. And this is called E1U, and the corresponding p orbital of the ligand is px. Now, these pi interactions or of the ligand to the metal, these is the most important of the three interactions that Cp has with the metal. These three types of interactions being delta, which we had discussed in our earlier class, and these two kinds of pi type interaction followed by the sigma interaction that we would be discussing subsequently. So, of the three types of interaction that a Cp ligand makes with a transition metal, all these four pi kind of interaction is by far the most important and the most favored one. So, the take home message is pi interaction is favored, dative bond between Cp E1 to Fe dyz dz is strongly bonding in nature. So, this is a kind of unique thing about metal cyclopentadienyl interaction. Let me just reiterate, the metal cyclopentadienyl interaction can be of three type. First is delta, which is weaker, followed by this pi, which is strongly bonding, which comprises of the maximum extent of bonding, followed by sigma. Now, usually the convention is that pi bond or pi interactions are always weaker than sigma. So, the conventional wisdom is that sigma is the most strongest component of bonding, followed by pi, followed by delta. But here we would see something more something unique happening. Here we see that sigma is almost non bonding. So, sigma is almost 0, pi is the most strongest component, followed by delta, which is weaker one. One can draw the sigma orbitals. So, these are ligand fragment molecular FMOs, and metal. The metal actually can interact with two orbitals. One is the S type as well as the dz square. Okay, and this is called A1G, and this is a sigma type interaction. Similarly, the other combination is This is called A2U. Corresponding metal orbital is Pz, and this also is a sigma type interaction. Now, this sigma interaction in metal is almost 0. So, Cp A1 G Fe Tz square is non-bonding. So, this is a very important take home message from this discussion, that usually sigma bonding interaction always are the most strongest form of interaction, and beyond sigma then the pi interaction happens. So, pi interaction never, in most of the cases, is a standalone interaction, because sigma involves head on overlap, whereas pi involves sidewise overlap. So, it has always been the case that pi interaction always occurs over and above a sigma interaction, but here in this transition metal cyclopentadienyl interaction, in what we find that sigma interaction is almost non-bonding, so non-existent, and the predominant nature or standalone form of bonding is indeed the pi interaction, followed by a very weaker delta interaction. As for this non-bonding sigma interaction is concerned, let me explain this through a simple drawing. Now, if one are to look at this orientation of Cp as well as the metal, so these sort of can be represented by a conical diagram like this, where these faces represents the Cp rings, and the metal represents this point. Now, if one were to look at these ligand orbitals, the Cp orbitals would be along the periphery of the ring, somewhere over here, same thing over here, whereas the metal orbitals will be in the core, will be somewhere over here. So, actually in principle the match or overlap between this peripheral orbital to that of the metal orbitals, which are directed at the center, physically would be almost none, and that is why it explains the non-bonding nature of this sigma interaction. For transition metal Cp interaction, sigma is non-bonding, pi interaction is strongly bonding, delta interaction of this type, Cpe2 is weakly bonding. Both sigma and pi represents ligand to metal interaction, whereas the delta interaction represents a metal to ligand interaction. Another important aspect is that metallocene complexes can exist in two symmetrical forms. One is the staggered form, and the other one is the eclipsed. The staggered form is more stable and its point group is 5D, whereas the eclipse form is D5H. Now, the important thing is that the orbital energy does not change, or bond energy does not change in going from the staggered to the eclipse forms. No variation in bond energy is observed among rotomers, eclipsed or staggered. Okay. Now, also the second important point is packing forces governs preferred conformations. So, with this I would like to conclude today's discussion, in which we have really looked into this cyclopentadienyl transition metal interaction right from the scratch, and then looked into how the orbitals interact with the transition metal, and we came up with the conclusion that this is a unique kind of interaction where the pi interaction is predominant, sigma and delta components are negligible or non-existent. And also we have looked into the variation of these orbital energies as a result of change from one conformation to other. So, based on this, we are going to do some more detailed molecular orbital treatment on this transition metal cyclopentadienyl interaction, and that would continue in the next lecture, and looking forward to taking up this topic in more detail in the next lecture. Thank you.